Good morning students. In the last class we have seen about chemical reaction, chemical equation, balancing of chemical equation. Now in this class we are going to study about types of chemical reactions. There are majorly 5 types of chemical reactions. The first reaction is combination reaction, second is decomposition reaction, third is single displacement reaction, fourth is double displacement reaction. Double displacement reaction is also called as precipitation reaction, and then redox reaction, which includes reduction and oxidation reaction. In today's class we are just going to see about combination reaction and decomposition reaction. So we start with our first reaction, that is combination reaction. Now students, the word combination itself tells about the reaction. Combination means to combine. So what is happening over there? There will be combining of substances. How it will combine? Just like in maths, 2 plus 2 is equal to 4. 4 plus 4 is equal to 8. 2 plus 2 plus 2 is nothing but 6. Similarly here the elements, compounds will start combining to give you a single product. So what happens? An example, A plus B gives you AB. So 2 elements, or you can say 2 compounds, combine to form a single product. So the definition says that the reaction in which 2 or more substances combine to form a single product is called a combination reaction. Examples: hydrogen plus oxygen gives you water. So here what we have seen, 2 elements combine to form a single compound is a combination reaction. Calcium oxide, also known as limestone, when reacts with water, it gives you calcium hydroxide plus heat. Calcium hydroxide is also called as quicklime. Now this quicklime is used in our daily life for whitewashing of walls. So in this process, if we see, there is also evolution of heat. So this reaction is also called as exothermic reaction. We are going to speak more about this. Let's have another example. Now, this reactions, whenever we speak about combination reaction, generally we consider combustion reaction as a type of combination reaction. What do you mean by combustion? So, when a substance burns in presence of oxygen to give heat and sometimes light is also called as combustion reaction. Now here we see that examples are burning of fossil fuel, coal, magnesium and sulfur. So as stated in the definition, you can also see that these substances will react with metals. Suppose oxygen reacts with metal, it will form metal oxide. If it reacts with non-metal, it will form non-metal oxide. So let's take an example. Magnesium plus oxygen gives you magnesium oxide. Remember in the first class we have seen the same. So here you can see magnesium ribbon is burned in presence of oxygen. What you get? You get heat and also light. Magnesium burns with dazzling flame. Okay, so we get light. So this process is nothing but a type of combination reaction also and a type of combustion also. Now in this process heat is also evolved. So this is also called as exothermic reaction. The reaction in which heat is liberated is called as exothermic reaction. So now let us see few more examples of exothermic reaction. In our daily life we burn coal. Coal is burned in presence of oxygen. So when coal is burned in presence of oxygen, you get carbon dioxide gas along with heat. So this reaction will be nothing but a combination reaction as well as combustion reaction. Now students, to tell you very clearly, every type of combustion reaction cannot be combination reaction. For an example, your mother cooks food in your house. She uses fossil fuel, that is natural gas. Natural gas contains methane. So when methane, CH4, burns in presence of oxygen, it gives you carbon dioxide plus water plus heat. Now in this process, it is not a combination but still a combustion reaction where heat is evolved. So it is an exothermic reaction. Another example of our body itself. We consume food. fluid contains carbohydrate, that is glucose. So it is C6H12O6, glucose. Then we respire, that is breathing, we inhale oxygen. With the help of oxygen, this glucose breaks into different substances, that is carbon dioxide plus water, and you get heat, but in form of ATP. This is energy which is used by us to do different work. So it is nothing but a type of combustion reaction. So in our body also combustion takes place, but there is no evolution of light. It's only heat which is produced. Another example, rusting of iron. That is iron when reacts with oxygen, it gives you rust, Fe3O4, and it is a type of slow combustion in which heat is also evolved. But the reaction is so slow that you do not come to know that heat is getting evolved. But in reality, there is evolution of heat and formation of rust. So rusting of iron is also a type of slow combustion reaction. So this is all about combustion reaction and combination reaction. Now students, we are going to see the next reaction, that is decomposition reaction. So in decomposition reaction, it is just the opposite of combination reaction. As I said, in case of combination, two or more elements they combine and form a single product. Now it is decomposition. What will happen over here? Here a single substance will break into two or more substances or simple products. So the definition is as such: the reaction in which a complex molecule decomposes into two or more simple molecules by application of heat, electricity and light is known as decomposition reaction. Yes, to break anything we will require energy. Now energy can be given in form of different waves. It can be light, it can be heat, it can be electricity. So let's see an example. A plus B, that is AB, a molecule is there. If you apply heat or electricity or light, it will break into A plus B. So this is nothing but a type of decomposition reaction where a single molecule, a complex molecule, is breaking into simple products. Now if we are breaking this molecule with the help of heat, so decomposition with the help of heat is called as thermal decomposition. When decomposition takes place due to electricity, it will be called as electrolytic decomposition, and when the decomposition will take place due to light, it will be called as photolytic decomposition. Now as in case of combination reaction, generally we said that in case of combination reaction heat will be evolved, and I said that combination and decomposition reactions are just opposite to each other. So in combination, as heat was getting evolved, so in decomposition heat will get absorbed. So such a reaction will be called as endothermic reaction. The reaction in which heat is absorbed, is taken in, is called as endothermic reaction, and decomposition reaction are generally type of endothermic reaction. Let us see some examples. Now the first example, here we are going to decompose copper nitrate. Copper nitrate is blue in color. When we heat this copper nitrate, it decomposes into copper oxide plus nitrogen dioxide plus oxygen. How will you come to know that nitrogen dioxide is what? Nitrogen dioxide is brown in color. So the gas of nitrogen dioxide is brown in color. So when brown color fumes are evolved, we say it is nitrogen dioxide. To elaborate this, to tell you more about this reaction, we are going to perform an activity and see the same reaction through a video. Okay.
take some copper nitrate in a boiling test tube. You can see that the color of copper nitrate is blue in color. With the help of Bunsen burner, start heating the test tube. You will see that slowly the color of copper nitrate starts turning, and after some time a brown color gas is evolved from the test tube. The brown color gas is nitrogen dioxide, and you can also see that there is a blackish substance which is left over in the test tube. This blackish substance is nothing but copper oxide.
Now, as seen in the above case, you have seen the video where with the help of heat we have broken copper nitrate into copper oxide, nitrogen dioxide and oxygen. Copper oxide which was formed was black in color, nitrogen dioxide was brown in color. Okay. Similarly, we are going to perform another decomposition reaction, but now with the help of electricity, that is electrolysis of water. So H2, when we provide electricity to water, at that time this water breaks into hydrogen and oxygen. Now let us see this reaction also through a video.
Electrolysis of water. Try this activity. Dissolve 2 gram salt in 500 milliliters pure water. Take 250 milliliters of this solution in a 500 milliliters capacity beaker. Connect 2 electrical wires to the positive and negative terminals of a power supply. Remove the insulating cladding from about 2 cm portions at the other ends of the wires. These are the 2 electrodes. Fill 2 test tubes up to the brim with the prepared dilute salt solution. Invert them on the electrodes without allowing any air to enter. Start the electric current under 6-volt potential difference from the power supply. Observe what happens in the test tubes after some time. 1. Did you see the gas bubbles forming near the electrodes at the test tubes? 2. Are these gases heavier or lighter than water? These gases are lighter than water as they are collected by downwards displacement of air. 3. Are the volumes of the gases collected over the solution in the 2 test tubes the same or different? No, they are different. It is found in the above activity that the volume of the gas formed near the cathode is double that of the gas formed near the anode. Scientists have shown that hydrogen gas is formed near the cathode and oxygen gas near the anode. From this, it is clear that electrolysis of water has taken place and its constituent elements have been released.
Now, in the above video, you have seen that water decomposes into hydrogen and oxygen. The amount of hydrogen liberated at one test tube was double than the oxygen. Why? The balancing of reaction itself says that twice H2O breaks into 2H2 and 1 O2. So automatically hydrogen evolved will be double. So the test tube in which there was more vacuum created was hydrogen gas, and the test tube in which there was less space created was oxygen gas. Similarly, we are going to do the photolysis. Actually, when the substance breaks with the help of light, it is also called as photolysis. So in this case, we are going to do the photolysis of silver chloride. Now silver chloride, when we put light on the silver chloride, at that time this silver chloride decomposes with the help of light, hence written as photolysis, into silver plus chlorine. Now this phenomenon was used in black and white photography. So for black and white photography, we use which substance over there? Silver chloride. Now same video, how does this happens? How it happens? We are going to see through an video.
Well, we can also use this energy, this light energy, to bring about chemical reactions. And this is, of course, the basis of photography. Now we have here a plate. We've made this with some jelly and some silver chloride. And at the moment, this is a nice white colour. Now we're going to put a mask over this and shine some light on it. Okay. So we have the white silver chloride. We're shining the light onto this now, and the light is causing a chemical reaction. The light breaks down the silver chloride and forms some silver particles. Now these are a very different colour from the silver chloride. The silver chloride is white. The silver itself, well, silver is a metal and slightly metallic coloured. We should be able to see some of the silver being formed in this reaction. So we just need to give it a decent amount of time in order for it to react. So let's try this. Okay. And if we hold this up, you should be able to see here, there we are, silver chloride going to silver. And this reaction is brought about by the light energy.
Okay. So students, you have seen all the three types of reaction in the video. Apart from this, there are few more reactions which I am going to tell you. The first reaction which we are going to see is ferrous sulfate, also called as iron sulfate. When we heat it, it undergoes decomposition. As we are using heat energy, it will be called as thermal decomposition. So on heating iron sulfate, you get iron oxide Fe2O3, plus you get sulfur dioxide, plus you get sulfur trioxide. So iron sulfate decomposes into iron oxide plus sulfur dioxide plus sulfur trioxide. Now iron oxide is brown in color. So at the end of decomposition, at the end of heating, you will get a brown color substance in test tube. So it will indicate it is iron oxide. How to find that sulfur dioxide and sulfur trioxide has evolved? So you will get a burning smell of sulfur. So burning smell of sulfur states that there is evolution of sulfur dioxide and sulfur trioxide. To balance this reaction, I will put 2 over here and the whole reaction gets balanced. Again, we are going to see the same reaction through a video.
4. 7H2O in a dry boiling tube. Hold the boiling tube with a test tube holder. Heat the boiling tube over the flame of a burner. On heating, ferrous sulfate crystals lose its water molecules and form white-colored crystals of anhydrous ferrous sulfate, FeSO4. On further heating, anhydrous ferrous sulfate decomposes to form dark brown-colored ferric oxide, Fe2O3, sulfur dioxide, SO2, and sulfur trioxide, SO3 gases. The gas emitted has the odor of burning sulfur. In this reaction, a single reactant FeSO4 decomposes to form 3 different products, Fe2O3, SO2 and SO3. So the reaction is a decomposition reaction.
Now let us see the next reaction. You have seen a reaction of copper nitrate. What if I take lead nitrate for decomposition? So let's see that example also. Now I will take lead nitrate over there in a test tube. Lead nitrate undergoes decomposition again in presence of heat. Again it is a type of thermal decomposition reaction. Remember, in case of copper nitrate, copper oxide, nitrogen dioxide and oxygen was formed. See the formula of lead nitrate, it is same as copper nitrate. So the reaction will also be same. What will happen? There, when copper nitrate heat was applied and it got decomposed, we got copper oxide plus nitrogen dioxide plus oxygen. So what you will get here? Yes, you are right. You will get lead oxide plus nitrogen dioxide plus oxygen. How you will see that nitrogen dioxide is evolved? Yes, brown gas fume. So brown color fumes are there. It indicates it is nothing but nitrogen dioxide. So in the same way, These are the ways by which we can see there is thermal decomposition reaction.
Now let's proceed the experiment. We need to heat it a bit strongly. As you can see, the decrypitation is taking place. As you can hear the sound, crackling sound. As you can see, the reddish brown fumes have started to come out. And now let me put the burning instance 6 inside. As you can see that the oxygen gas is making the flame more brighter. Oh, done, superb. So as you can check the presence of oxygen gas with the help of burning splinter. The oxygen gas burns the splinter, and here we have the NO2 gas as well. So hopefully guys, you have understood the demonstration. Please make sure that this reddish brown gas is very toxic. So whenever you carry out this experiment, you carry out in open.
Example of decomposition reaction is decomposition of calcium carbonate. Calcium carbonate on heating, if we heat calcium carbonate, it decomposes into calcium oxide plus carbon dioxide. So now calcium carbonate is nothing but marble. The formula of marble is CaCO3, that is called as calcium carbonate. On heating it decomposes into calcium oxide plus carbon dioxide. How to identify that carbon dioxide is involved in this process? So now here you take lime water and pass this carbon dioxide through lime water. So what will happen? Formula of lime water, we have prepared this lime water, that is slaked lime, that is calcium hydroxide. When carbon dioxide gas is passed through calcium hydroxide, it gives you calcium carbonate plus water, and calcium carbonate precipitated forms white color substance. So what will happen? Water will start, the slake lime, that is lime water, will start turning milky, and this substance which will be formed is calcium carbonate. So in this process you can identify that carbon dioxide gas is involved. This is chemically. Second method, nothing you have to do. In a test tube we are doing the process. Take a burning matchstick towards the mouth of test tube. What will happen? Carbon dioxide gas is getting involved. So the matchstick will get extinguished. But this does not give confirmation of carbon dioxide gas, because there are many gases which does not support combustion. So to find whether it was carbon dioxide gas only, what we have done? We have used lime water. So when carbon dioxide gas is passed through lime water turns milky. So again, this was a type of decomposition reaction.
In this reaction, you can see that when calcium carbonate is heated, it decomposes into calcium oxide and carbon dioxide gas. Carbon dioxide gas, when passed through lime water starts turning milky. This can be seen through the test tube.
So students, today we have seen two types of reaction. We have seen combination reaction and decomposition reaction. Combination reaction and decomposition reactions are just opposite to each other. In case of combination reaction, there will be combination of elements, while in case of decomposition reaction, a single element, a single compound will break into simple products. Along with this, we have also seen endothermic reaction and exothermic reaction. In case of exothermic reaction, heat is evolved. In case of endothermic reaction, heat is absorbed. That's all for today. In the next class, we will be studying about single displacement and double displacement reaction. Thank you everybody and have a nice day.